Hello, my name is Max. Welcome back to this chapter about digital sound recording. Today I want to talk about a really important tool in every sound recording toolkit, which is a parametric equalizer. A parametric equalizer allows you to boost or attenuate certain frequencies in your recording. So if your voice has certain problems, if your voice is really harsh, for example, you can treat this with a parametric equalizer. Now, the sound in this episode, ironically enough, might not sound as good because I'm actually going to show you the sound recording software, so I cannot use the software to record. I have to use XSplit, which doesn't have as good a sound quality, unfortunately. But anyway, I'm going to show you how to use a parametric equalizer and how to find problems in voice recording. Another word of warning: what I'm going to say is not general, because there are no general answers what you should do with a parametric equalizer. It's different for every recording. It depends on what you want to do. But I'm going to show you what people usually tend to do, and I hope it will help you. So let's actually jump into the program. Alright, so what you see here is a parametric equalizer. I'm going to use Adobe Audition here, but it's basically the same as every sound recording software. So the blue line represents the volume change over frequency. That is frequency and that is volume, okay? I can grab one of those points and I can make certain frequencies, let's say 1 kilohertz, louder or less loud. Now you see that when I move this around, it not only affects 1 kilohertz, it also affects the frequencies next to it. Now, the way I can change this is I can change Q. Q tells you how narrow the frequencies changed are. Q of 0 means that all frequencies are changed. And a really high Q, about 10, that's really narrow, and then it gets really, really, really narrow. So this way you can either affect a broad range or you can affect a really narrow range. A general rule is you want to cut, okay, you want to cut narrow, and you want to boost wide. That's a general rule. Another general rule is you usually want to cut more than you boost, okay? If you cut, you can go quite far down like this. This is quite far. This is actually too far. So maybe minus 15. You can do that. But if you boost, if you would go to plus 15, it would sound that would be craziness. It would sound like crap. Anyway, now to actually show you what people usually do. Now the first thing you want to do is a high pass filter. A high pass filter lets high frequencies pass, hence the name. That's actually a little bit too much. Now, why would you apply this to your vocal recording, and why should it be at 75 Hz? Well, the reason is that usually human voices don't go this low. Human voices start at about 125 Hz if it's a really deep voice. So everything below that you can cut off without actually altering the recording too much. So I could actually show you the recording, usually you don't hear it. So why should you apply it? Well, there are sounds you record below 75, or some people even go to 100, that are recorded, but those sounds are not your voice. Those sounds are popping noises, rumbling in the background, trucks driving by, vibrations in, vibrations in your microphone stand, stuff like that. That's stuff you do not usually want in your recording. So a good first step is to have a high pass filter always. Only if you know that you really, really, really actually want to record really low frequencies. If you want to record a bass guitar, if you want to record a bass drum, a kick drum, then you should not use a high pass filter. Apart from that, always use a high pass filter. So that is the first thing you should do. Now we can listen to a recording before and after. You usually shouldn't hear a difference. My name has been Max. Thanks for watching this episode, and tune in next time. And before you yell at me, yes, I know I have too much noise filter. It's for reasons for this tutorial that I did this. Okay. Now let's activate it. My name has been Max. Thanks for watching this episode, and tune in next time. My name has been Matt Max, thanks for watching this episode, and tune in next time. I think there's a slight difference, it's very slight. You might actually do not hear it because of the compression of XSplit. I actually can hear a slight difference with the high-pass filter. It sounds a little bit better, a little bit clearer. What often happens is that your sound recording sounds muddy. If it sounds muddy, a high-pass filter can actually help you. So that is the first thing you do. What else should you do with your voice? Well, that depends on your voice. I cannot tell you what exactly you should do. But a good way to find out is the following. You boost a very narrow frequency range and you boost it a lot, and then you're going to sweep it around the frequencies and you're going to listen to how it sounds. If you have a problem with your voice at some point, you are going to hear it better if you boost it up a lot. If you have something in your voice that sounds really good if boosted, you hear it too. So let's actually listen to that. Max, thanks for watching this episode, and tune in next time. My name has been Matt Max, thanks for watching this episode, and tune in next time. My name has been Matt Max, thanks for watching this episode, and tune in next time. My name has been Matt Max, thanks for watching this episode, and tune in next time. So you hear that we have still a little bit of noise in the background. Those are also really sharp sounds you heard there. And you hear that my voice sounds pretty good already, which is the reason I usually don't use a parametric equalizer. But if you have problems in your voice, the best way to find it is this way. You slowly sweep across all the frequencies and you listen to it. And if you hear, oh, this part of my voice sounds really harsh, this part of my voice sounds really good, then you know what to boost and what to attenuate. However, I built an EQ that already has all the standard stuff people usually do to vocal recordings. I don't use it because my recording usually sounds pretty good already, but I'm going to show you nonetheless. Alright, so the EQ I built is called Samson CO1U Standard. That's my microphone, and it's going to be different for each microphone, obviously. Well, so that's the standard stuff people usually do, and I'm going to walk you through all those 5 things, so you understand why they're there for. However, again, it's going to be different for every voice. I don't use this. I just build it to actually show you what people usually do. So first thing is a high-pass filter. We already talked about that one. Next thing is a boost from 200 to 600 Hertz. That's bass. Let's actually see if you can hear it. Thanks for watching this episode, and tune in next time. My name has been Matt. That was out, and now let's activate it. Max, thanks for watching this episode, and tune in next time. My name has been Matt. You hear it a little bit. It sounds a little bit deeper and better, okay? So that would be one thing I might do. I don't, but I might, I would do it. It sounds a little bit nice, okay? So, next thing, this is number 4 here. It's somewhere between 1 to 2 kilohertz. This is what makes this voice sound a little bit softer. It's difficult to describe, and it doesn't really make a whole lot of a difference for my voice, so I'm not going to show you, but people usually cut this, and they cut it narrow. Again, general rule, boost wide, cut narrow. Then the next thing, that's where you have harsh sounds. It's between 2.5 and 4 kilohertz. That's why you have harsh sounds, and you usually want to cut out. Lastly, you see I boosted another frequency, number 5. And this I can show you too. It's always easier to show a boost than a cut. Now, this is what makes your voice sound bright, right? Airy. So let's boost this a bunch and actually listen to it. Thanks for watching this episode. Oh, too much. And tune in next time. My name has been Matt Max. Thanks for watching this episode, and tune in next time. My name has been Matt Max. Thanks for watching. So you hear the difference right away. It sounds brighter. It sounds more present somehow. So people tend to boost that. Now actually you need the other points to see how high it should be. I guess it was like this. So the end product of all of those changes together. Let's listen the last time. I know you're already sick of it. Let's listen the last time to the original. My name has been Matt Max. Thanks for watching this episode, and tune in next time. Now we activate the EQ. My name has been Matt Max. Thanks for watching this episode, and tune in next time. I don't use it. I don't think it sounds that much better. I think my voice sounds pretty okay right from the get-go. But again, that's something you have to decide on a case-by-case basis. It might be that your voice actually profits greatly from a parametric equalizer. Or it can be that your voice does not profit from a parametric equalizer at all. Nonetheless, it's good to know how it actually works and what can be done. As a side note, if you mix audio and if you record a band, you can also use this. For example, the acoustic guitar is in the same frequency range that your vocalist is in, then you can cut the acoustic guitar in this frequency range so that you hear the vocalist better. Usually in an audio recording, you want, if you mix a band, you want the whole frequency range, but you want every instrument to have its own range, okay? Every instrument should have its own band so they don't overlap. But that's just a side note. So, yeah. What can I say? My name has been Matt Max. Thanks for watching this episode. And see you next time.